Have you ever wondered how we prove a new idea really actually works? Well, it's not magic, that's for sure. It's all about having a blueprint. Today, we're diving into research methodology, which is really just the official name for that structured plan that turns simple curiosity into a credible discovery. So, let's imagine this. A school rolls out some new, high-tech way of teaching math. The principal says it's way better, but how do we know? We can't just take their word for it, right? We need a solid, reliable process to find out the real answer. And that is exactly what research methodology is all about. You know, every great research project starts out just like building a house. You've got to have a solid blueprint. This first stage is all about laying that foundation, going from a really broad topic to a super specific, testable question. And the process itself is incredibly logical. First, you pick a topic, like our new teaching method. Then you do your homework. You review what other people have already figured out, looking for a gap in our knowledge. From there, you form a hypothesis. That's just a clear, testable prediction. And finally, you choose the right tools, the right methodology to actually test it. This slide really breaks down our hypothesis perfectly. The independent variable is the one thing we're going to change. That's the cause. For us, it's the new teaching method. Then you've got the dependent variable, and that's what we measure to see the effect. So in this case, it's the student's test scores. See? It's a really clear-cut way to frame the cause and effect we want to investigate.
All right, so we've got our blueprint in hand. Now it's time to gather the raw materials for our project, the data. This is the evidence, the stuff we're going to use to see if our hypothesis actually holds up under pressure.
And data, well, it pretty much comes in two main flavors. You've got primary data, which is what you go out and collect yourself, like, say, surveying students directly for your study. Then there's secondary data, which is information someone else has already gathered, like using national education stats from a government census. Both are super useful, just for different things. Data also shows up in all sorts of formats. You've got your structured data, which is all nice and neatly organized in rows and columns, like a bank statement or a spreadsheet. Unstructured data is the complete opposite. Think about all the messy, unpredictable text in a random social media post. And then there's semi-structured, which is somewhere in the middle. It's got tags that give it some organization, kind of like an email. Okay, now we hit a major practical challenge. If we want to study our new teaching method, we can't possibly test every single student in the country. I mean, can you imagine? So we have to pick a smaller, manageable group that can represent the whole population. And that group is what we call a sample. And there are two main ways to do this. First, there's probability sampling. That's where everyone in the group has a known chance of being picked, which is the best way to reduce bias. On the other hand, you have non-probability sampling, where the selection isn't random. It's usually quicker and cheaper, but you have to be way more careful about potential bias creeping into your results. The purest form of this, the gold standard really, is simple random sampling. Just think of it like a lottery draw. Every single person has an equal, totally unbiased shot at being selected. But what if you need to study a group that's really hard to find? Say, people who have fallen for a very specific online scam. That's where you get clever, non-probability methods, like snowball sampling. You find one person, and then they lead you to another, who leads you to another, just like a snowball, getting bigger and bigger as it rolls downhill. It's a pretty cool technique. This slide here is basically a cheat sheet of all the different tools a researcher has. For example, with stratified sampling, you make sure you get the right proportional mix, like maybe 60% arts and 40% science students, if that reflects the school's population. And then you have convenience sampling, which is pretty much what it sounds like, just asking whoever is easiest to find, like people at the local mall. Each method has its own place. Feel free to pause here and just explore the different options. Okay, so we've got our blueprint, we've got our raw materials. Now for the really exciting part, the analysis. This is where we get to sift through all that data, look for patterns, test our hypotheses, and turn what was just a big pile of numbers into a story that actually makes sense. So sometimes we start simple by just looking at one variable at a time. This is called univariate analysis. And a simple bar chart like this one, it's a perfect example. We can see instantly that science is the most popular subject in this group, then math, then English. It's just a quick, clear snapshot of the situation. But things get really interesting when we start comparing two variables to see if they're connected. This is called bivariate analysis. What we're looking for is a relationship or a correlation. You know, like as the number of hours someone studies goes up, do their marks also go up? That's the kind of connection we're looking for. So, how do we actually test for that kind of relationship? Well, a simple table like this is a great place to start. Here, we can compare gender with a preference for sports. Researchers then use statistical tests to figure out if the pattern we're seeing is a real, significant connection or if it just happened by random chance. Now, this number here, 384, illustrates a really crucial point about confidence. To get results you can rely on, you can't just ask a handful of people. In fact, for a population of 10,000, you'd need to survey at least 384 of them to be 95% confident that your findings aren't just some random fluke. Sample size is absolutely a science. And that brings us to the final and maybe most important step, the integrity check. After all the hard work is done, we have to ask the tough questions. Is this research solid? Is it valid? Is it reliable? And crucially, was it conducted ethically? Two words here are absolutely critical: validity and reliability. Validity asks, are you actually measuring the thing you think you're measuring? I mean, a driving test that only had written questions wouldn't be very valid, right? And reliability means your results are consistent. If you take a personality test twice, you should get a pretty similar result both times. You really need both for solid research. And beyond just being accurate, research has a moral compass. Researchers must get informed consent, which means people know exactly what they're signing up for. They have to protect their participants' privacy by keeping data secure and anonymous. And they've got to make sure their methods are fair to everyone involved. And look, these aren't just suggestions. They are fundamental rules of the game. Academic integrity is also a huge deal. We all know plagiarism. Passing off someone else's work as your own is a massive no-no. But what's really interesting is this concept of self-plagiarism. That's reusing your own work from a previous publication without citing it. Now, it's not quite the same as stealing, but it's still considered an ethical misstep. Which brings us right back to where we started. This quote just perfectly captures the whole idea of our explainer today. A good research methodology isn't just a list of steps. It's an entire strategy, a detailed blueprint that makes sure the final structure, the discovery itself, is sound, sturdy, and something you can actually trust. So the next time you read a headline about some new study, don't just skip to the conclusion. Ask about its blueprint. How did they pick their sample? Was their measurement tool valid? Was it reliable? Asking these questions is the first step to becoming a much more critical and informed consumer of information in your daily life.
Thanks for joining us.